Hey guys, we are going to start a new unit today, and it is called Rational Expressions. And the word expression means that there is no equal sign. So basically, we're going to be looking at the biggest fractions on the whole planet, and our goal is just to simplify them. We want to simplify everything. That's our entire objective, is to simplify, cancel things out, and make things as small as possible. So again, these are called expressions because they have no equal sign, and they are rational, which generally means they're made of rational numbers. So let's take a look at this. So let's go way back to the basics. Let's say we've got, 6 over 8. That's just a fraction. And if I asked you to simplify this, you would look at this and you would say, okay, well, that is the same as what other fraction? Well, if I simplify this, what you're really doing in your head is you're saying that you can divide both of these numbers by 2. And if you do that, you're going to get 3 and a 4. So 3/4. Is there another number that 3 and 4 both divide by? Like these both divided by 2? No. So this is simplified, right? So we know this. So over here, this 2 that we just used to divide both of these by, that's a factor, right? We can divide them both by the same factor. So if we take this up a notch, we would look at something like 18 over 27, but let's throw some variables in here. 18x to the 6th over 27x to the 4th. So I have to be really good with divisibility rules here. Like, what can 18 divide by other than 1? It divides by 2. Does it divide by 3? Yes. Does it divide by 4? No. Does it divide by 5? No. 6? No. 7, 8, 9. And, I missed 3 and 6, didn't I? 6. Okay, what does 27 divide by? Does 27 divide by 2? No. Does it divide by 3? Yes. 4? Nope. Does it divide by 5? No. 6, 7, 8, 9? It divides by 9. So if I look at this, what of these factors does 18 and 27 have in common? Well, they both divide by 3, but they both divide by 9. So 9 is the biggest number that they divide by. We can use 3, but 9 is going to be more efficient. So if I divide 18 by 9, I get 2. And if I divide 27 by 9, I get 3. So that means 18/27 simplifies to 2 over 3. Now let's look at the x's. On top we have 6 x's, and on the bottom we have 4. So if we start to cancel those x's out, how many are left on top? 2. So we have x squared on top. The faster way is that, if you take away 4 of the 6, you're going to have 2. But this is why that works. So our simplified expression is 2x squared over 3. All right? Now, what if we throw a negative in there? Nothing really changes. Let's look at this one. What if we have negative 16 x squared y to the 7th over 12 x to the 5th y to the 3rd z to the 4th. All right, so we're going to do this in pieces. We're going to start by just looking at our whole numbers. After that, we're going to simplify our x's. Then we're going to simplify our y's. And then at the very end, we'll simplify our z's. If you want to pause right now and try this one, it's a good time to do it. Okay, let's start with negative 16 and 12. First of all, when you have a negative, it doesn't really go away. It's not on the top, it's not on the bottom, it's just it's the entire fraction that's there. So it doesn't really matter where you draw it. All right, 16 and 12, they both divide by 2. They both divide by 4. They both divide by, that's about it, 4. So if we divide both of these by 4, 16 divided by 4 is 4, and 12 divided by 4 is 3. Now, our x's, so you've got 5 x's in the denominator and 2 x's in the top. Well, if we cancel out 2 of those, because it's the smaller number, you're going to have 3 x's left in the denominator. For your y's, this time we have more y's in the numerator. So 7 in the top, 3 in the bottom. That means 3 will cancel out. And how many will be left in top? 4. For your z's, there's none in the top, so we can't cancel anything. So all 4 z's will stay in the bottom. Therefore, negative 4y to the 4th over 3x cubed z to the 4th is our final answer. Did you notice how I drew my fraction at the very beginning, and then I just kind of very carefully went piece by piece and just placed things in the top or the bottom? I'm very organized about that so I don't mess myself up. How do we feel about that? Is that okay? Okay, good. So let's move on to the next level, if you will. Now, let me come back to this. Here's what I want you to notice. In this, do you see how this is just one term in the top and one term in the bottom? There are no addition or subtraction signs. There's a negative, but a negative is different. I'm talking adding and subtracting. There's no adding and subtracting here. So now let's look and see what happens when we do put some adding and subtracting in. So if we have 2x plus 6 over 4x minus 12. These have 2 terms in the top and 2 terms in the bottom. I know they're different terms because of the separation between the operator, between the addition and subtraction. So I have 4 terms. Oops, let me highlight that. I have a red term, I have a blue term, and the sign is always to the left, a green term, and a yellow term. In order to cancel something out, all of the terms must have the same factor. So let me give you an example. So they all must have the same factor. Let me write that down. So for example, if you had, let's make one little change, 2x plus 6 over 3x minus 12. Here, in the top, okay, let me back up. In the top, I can divide 2 by 2. I can divide 6 by 2. I can divide 4 by 2. And I can divide 12 by 2. They all divide by 2. Perfect. That means we can do some simplifying. Down here, 2 divides by 2. 6 divides by 2. 3 does not divide by 2. 12 does. But because this 3 doesn't, there's nothing we can do. We are not allowed to be like, oh, let's cancel out that 2 and make this a 6. And oh, here's a 6 and here's a 6. No, 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 no. Not allowed. So, because I know that's what you want to do, the rule is you have to be able to factor something out. You have to factor something out. If you can't factor it out, you can't do it. So, think back to what we know about factoring. 2x plus 6, what do they have in common that we could factor out? Well, they both divide by 2. So I'm going to factor out a 2. If I do that, it leaves me with x plus 3, right? In the denominator, I have a 4 and a negative 12. Well, what's really the best thing to factor out there? I would factor out a 4. So if I factor out a 4, that's going to leave me x minus 3. So now that these two are factored out, I can look at this. Because they're multiplying, they are not separated by addition. I can look at those and say, well, 2/4 is the same as 1/2. So that 2 cancels, and this is a 2, right? So then my final simplified answer is x plus 3 in the top and a 2 x minus 3. So that works. Now, I hope, someone is saying, well, is there a different way to do this? And there is. You could have said, you could have done the 2x plus 3 in the numerator, and then in the bottom, you could have factored out just a 2, and that would have left you 2x minus 6, and then your 2's canceled, and your answer would have been x plus 3 over 2x minus 6. That's also okay. These two things right here are the same. One is distributed and one is not. So that's totally fine. It just depends on what your goal is. Typically these problems would be embedded in a bigger problem and we would care, maybe there would be a more efficient way or something else. But for right now, either will work. Okay, let's try another one. What if we have 3x minus 15 over 4x minus 20? All right, let's look at this. So again, we can't just start taking things out. We have multiple terms, and it doesn't appear 3, 15, 4, and 20. Off the top of my head, there's nothing they all divide by. So I'm going to look individually. In the numerator, 3x minus 15. 3 and 15 can both divide by 3. So I'm going to go ahead and do that. And that's going to leave me x minus 5. So 3 times x minus 5. In the denominator, 4 and 20, what do they both divide by? Well, they both divide by 4. So if I factor out a 4 here, I'm going to be left with x minus 5. Well, look at this. My 3 and my 4 won't simplify, but x minus 5 is in the top and in the bottom. Because they're multiplying, because they're separate terms, and maybe you need to put brackets around all the pieces. So you can only cancel brackets that are in the top and the bottom. So in that case, these two pieces will cancel, and all you're left with is 3/4. So the moral of the story here is you can cancel brackets, or like in our last example, you could cancel numbers. The key is is that you can only cancel things that are in brackets.